Earlier this week, the world may have changed forever. No, it's not because I finally figured out who was stealing all the water off the top of my Greek yogurt. It's because Cheng Liu, a former React core team member and engineer at Midjourney, claims to have crawled through the depths of hell to bring us pretext, a fast, secure, accurate, and comprehensive text measurement library written in pure TypeScript. Now, I know if you don't have a deep, innate interest in trains, that might sound boring, but it's actually a massive game changer for UI development. Ever since Al Gore invented the internet, rendering dynamic text has had a performance trade-off. When the browser needs to figure out how tall a paragraph is or where to break a line, it has to trigger a layout reflow, which often calculates the position and geometry of every element on the page. This reflow is one of the most expensive operations a browser can perform, but it's also what the browser needs to do whenever you ask it for the height of any text element. This makes it unreasonably difficult to build any sort of text-heavy UI, like a virtualized list or a masonry layout. But now finally in 2026, with pretext, you may be able to smoke your crack and eat it too. In today's video, we'll look at its crazy engineering under the hood and find out if it lives up to the hype. It is April 2nd, 2026, and you're watching The Code Report. A decade ago, while the rest of us were busy having premarital relations and mourning the death of Harambe, Cheng Liu spent his time studying the blade of front-end infrastructure at Facebook, while also building React Motion, one of the most popular animation libraries in the React ecosystem. So when a person with his experience says they're releasing what they believe will be one of the most important foundational pieces of UI engineering, they're either in the midst of a deep episode of AI psychosis or they're onto something big. Either way, it makes for a good story. But what exactly makes pretext so foundational? Well, Cheng figured out a way to bypass the typical browser text rendering pipeline that was designed during the Clinton administration when websites look like this. Now let's imagine you're building a chat app for train enthusiasts. It needs to be fast or else users will blast you on Blue Sky for not caring about poor people. But the problem is that the main view in your app has a scrollable list of 10,000 messages. You typically handle this by creating a virtual list where only the messages the user can see get rendered to the DOM. But in order to do that, you first need to know the height of every message so you can then calculate the total scroll height and then use that to decide which messages should be visible. But how do you even do that? You could render each one and then measure them, which would be slow. You could try to guess, which would be wrong, or you could give up and find a new career. Or now, you could use pretext. What Cheng figured out is that you don't actually need to ask the browser for text dimensions at all. For getting the width, he used the Canvas API, which lives outside the DOM and gives you the pixel width of any string in any font without triggering reflows or layout calculations. But then for getting the height, he had to write a custom algorithm that took into account how every browser across every language handled line breaks. As you can imagine, determining all those rules would be near impossible to do alone, so he summoned a few clankers into a recursive hellscape and had them do the dirty work. He'd have them write the line break logic, then test it against actual text in actual browsers and compare the results. He then had them repeat this process for a few weeks until the algorithm was solid and the clankers were begging for the sweet release of death. And the result of all that suffering is a surprisingly simple API. You first prepare your text, which breaks it apart into segments and then caches each segment's width. Be quiet, dog, I'm making a video. Then you call layout, which gives you the total height and line count of that text, all without ever having to touch the DOM or trigger a reflow. It all sounds so simple, but if you can do these calculations without the cost, you can build some pretty crazy apps. Take this one for example. I know many of you have a hard time watching our sponsored segments, so I built an app where you can both read the transcript of every video while you also watch the upcoming sponsored segment. But what's not to love? Here's how it works though. First, we run the script through pretext prepare with segments function, which breaks it apart and catches the pixel width of every segment. Then we call layout next line in a loop once per row on every screen to figure out exactly which characters land in which column. The end result is a grid where every cell knows its character. From there, we draw the video onto a tiny off-screen canvas that's exactly as wide and as tall as our character grid. We then read back the raw pixel data and calculate the brightness of each pixel, 1 pixel per character cell. Finally, we put them together, so for each cell in the grid, if the corresponding video pixel is bright, we draw the character bright. If it's dark, we skip it entirely. And essentially, the video image forms itself out of letters, using brightness to sculpt what you see. The pretext handles the hard part of knowing exactly where every character belongs, and the canvas handles the rest. Pretty cool, but whether pretext becomes the foundation Cheng Liu thinks it will or not, at the very least, it's proof that the browser doesn't have to own text measurement anymore. But another project that's literally changing how we build web apps is JetBrains, the sponsor of today's video. You already know about their AI coding agent, Junie, that's built directly into the JetBrains IDE. Well, now they just launched Junie CLI, CLI, so you can use it everywhere. You just install it from the terminal with one command, then start assigning tasks to it. I've recently been using the CLI to build a tool that analyzes all of my dependencies in a project and tells me how screwed I am on a scale of 1 to 10. I've found that Junie is usually able to handle more complex responsibilities than other coding agents I've tried, and that's largely thanks to IntelliJ IDEA's deep understanding of your project's architecture. I also like how Junie automatically switches.
Okay, so let's get started. Okay, Kaden has baseball game. Okay, so I'll paste the GitHub link in the chat, as well as my share. People that want it, and I'll share my screen. So for this week's project, it'll be more simpler than what we were working with last time. This time we're going to do some Q-learning agent. Actually, let's show the VS Code. Okay, so we're basically going to do something called a GridWorld layout. And so first, we're going to have two classes, the GridWorld and the Q-learning agent. And then a couple of functions like the training agent, the plot value function, plot the policy, play greedy, animate greedy. So greedy means greedy search. It's a type of searching algorithm. I don't know if you guys probably don't know it, but it's basically the most basic one. So let's make it, I'll tell you after. Okay, greedy search, and then the main function. So then the grid world will be our environment for this Q-learning agent. So we're basically mapping out a 5 by 5 of it. Yep, 5 by 5 map, and it's gonna have some holes in it that the robot can't go, and it's gonna have a start and a goal square, and it starts from the start square and it ends up in the goal square, and it tries to avoid the holes, and it goes there in the least amount of actions as possible. So basically, this one is going to be grid world class. It's just going to have like these steps. So make an action towards this other cell, get all the valid actions. So remove the holes, and then rendering the grid. And then the Q learning agent will be our learning agent. So basically, we have this init function. So this one you guys should already know. It's just a constructor. So when you guys call Q-learning agent, we set these variables by whatever the arguments the user passed in. And then we have select action, update, normal functions that you guys have seen when training agents. And then we have the train agent, which is the training loop. Then after we're done, we'll have this plot value function, which will, as it says, plot the values. And the policy, you guys won't implement this. And then we'll have the play greedy and the animate greedy as well for after we're training this Q-learning agent. We'll use this agent to play through that grid world. So play greedy just decides what move to learn next and move to do next based on the Q-learning agent that we trained. Animate greedy just animates it. And then finally we have the main one, main function, which just we just call the functions that we made. So a quick demo. Okay, let's see. Final. Wait a bit. So the reason there's a error here, it says command not found in Python. So my Python can't be called using the name Python, but it needs to be, I have to activate my virtual environment first, and then I can run it. Now you guys can see here, this is what you guys are expecting. So you guys will have this plot or the grid of all our values after we trained our Q learning agent. So like 0.90 would be better than 0.0. So it's just ranking each square as which one's better. Now, once I exit this, it will start the greedy search as well as the animate greedy. So it should, yeah, show in the CLI. So H means whole, A means start. I mean, A is the robot, and then G is the goal, and S is the start. So first it's at S, then it goes down. You guys can see it moving down, right, down, avoiding the hole, right, down, down, right, and then to the goal. So you guys can see it stops after 8 steps. Now, what else was it? Oh yeah, research. Let me share my screen. Okay, okay. Then let's get started with coding. Adam, can you share your screen? And then we'll just start off with the template file. So either open up the GitHub, copy the code, or download it, or just open up the live share. Up to you. Uh, so the link is in the chat for GitHub and the live share. And then after Adam, Albert will be next. So just get ready or be ready. And then
It's the same.
the live share. Weird, it says it's running on mine. Maybe try this again. This thing never works, does it?
Your share is still the
Oh,
same.
my share is the. Oh, okay, okay. It should be good now. Yep, should be good. Okay. Then we'll start with reset. So the GridWorld class has a reset function. Should be right under constructor. So go up. Right there, you see the init? That's the constructor. It should be right below it. The reset. Yep. No, no, the function, yeah, definition. Yep. So as you can see, the function argument has self, which is referring to that class. So it's saying I can use any of the classes variables that were initialized in the constructor. That's what the self represents. And then it's returning a tuple of int by int. So for this one, as it says, we're just going to place the agent back to the start. So we're going to do self dot pos as in position equals start, all caps. And yeah, start is defined all the way at the top. So just so you know, and then enter return self dot pos or position. Yep. And then do step as well below it. No, the next function. So you can see that the arguments are self again and action, and then it returns a tuple of a tuple and a float and a bool. So we're basically gonna move the agent and return another tuple that says this is the next state, this is the reward we had, and done. And done's gonna be a Boolean value. So true means that we're done, and then false means that we're not done. So first let's do dr comma dc equals all caps actions, and then we're going to access the action. So do the square bracket. If you hover on actions, you should say that it's a dictionary. And then inside it, you want to do action. And action is from the function argument. You can see it there. Action is an int. Next, enter, you want to do r comma c equals self.pos as in position. Now for this one, you see that position or POS is not passed in as an argument and it's not kind of initialized inside this function. The only reason you can use it right now is because of that self. So basically, if you ever like initialize a variable from any other function using self dot blah 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 equals, then you can access it from any of the other functions inside that class. So now the enter nr comma nc again equals r plus dr comma c plus dc. So we're basically adding the direction to the current position. Yep, and then enter. Now we want to keep the agent inside the grid. So what you want to do there is check if we're outside the grid, right? So if nr is less than 0, so if the new row value is less than 0, then that means the row value is -1 or something, which doesn't exist on the board. Then you want to reset it, right? And then do or. You want to check the other side, nr greater than or equal to rows, all caps. Rows is defined as 5. And then do or. Now you want to check the columns, so NC is less than 0, or NC is greater than or equal to cols, as in columns, but all caps. Yep. And then you want to do the, what do you call it? Column. Remember, it's the if statement. Wrong one. Wrong sign. You did a semicolon, you need a colon. Yep. And then enter. Yep. So then do nr, comma, nc equals r, comma, c. So if we're exceeding it, then we want to just remain where we are. Enter. Backspace outside of the if statement. Now we want to do self.pos equals tuple. So that means circle bracket. Or you can do tuple actually. Tuple and then function. So circle, yeah. nr, commas, nc. Yep, that also works. And then do next line. Now you will do number 5, which is return the position, reward, and done. So do if self.pos position or pos equals goal, all caps, OAL. Yep, it's defined as 4, comma 4, which is the bottom right. And then you want a colon. So that's a semicolon, you want a colon. Yep, enter. Then do return self.pos, comma, 1.0, comma, true. True in Python is a capital T. Yep. So basically we're saying we're at this position. We arrived at the goal, so we give it a 1 score, and we're done, so it's true. Enter, backspace. Now you want to check for holes. So if or elif, self.pos in all caps holes. In. Yeah. Remember the colon. Yep. Return the self.pos, comma, -1.0, comma, true. So we arrived at a hole. So we're gonna do, okay, we're at this position. We're gonna give it a -1 since we died. We fell in the hole and we're done, so it's a true. Enter, backspace, and then you can just do return self.pos, comma, -0.01, comma, false. False, capital F. You need a comma there. Yes. So this one is interesting. So if you didn't arrive at the goal and didn't arrive at the hole, then you're in the middle somewhere or off to the right somewhere, just somewhere that's not the goal or the hole. So you return the self-dot position. You say it's false as in we're not done, but we're giving it a -0.01. Do we know why? Why do we want this value?
Because so it spends longer, then it loses more points.
Yeah, that's exactly right. So basically, we're subtracting value because we're spending more time to find that goal. We want the less movements as possible. And the reason it's 0.01 is because we don't really want it to affect the final goal of reaching the goal, right? So it should be way less than 1.0. Or else if it was 1, then it would just be keep on moving back and forth. And that would maximize everything, like to infinity by how many times they move. But yeah, you're right. And you can stop sharing. And Albert, you can stop. start sharing. And that's all right, James. So Albert, if you can share your screen, and after Albert, Charlie, you'll go next. So just be ready with the GitHub or share. And so for this one, get valid actions. So Albert, do you do you use Git or do you just copy the file and stuff? Okay, okay. So let me push my code right now. So you can do git pull. Okay, I see. Okay. Whatever. We can just do it. Unless you want to git stash. Up to you. And then git pull. So do 9. So it should be reset step we did. And then next we'll do get valid actions. So one below. Yeah, that one. And then tab. Oh, okay. So get valid actions is one line. We want to just return the list of valid actions. And then we can just move on to render. And then this one, so we're basically doing print a quick ASCII representation of the board. So we're going to use this later for when we're after the training of the Q value and we do the greedy search. Then we represent like the A for the agent, and then the G for the goal, and the S for the start, and H for the holes. So you do board equals numpy or np dot full, and then you're doing rows by columns, which is 5 by 5. And you're basically saying each cell is a dot, and yeah, it's a string. So the data type is a string, and then for each row and column, or whole row, whole column in holes, then you want to do boards that whole equals H, and then you want to do it for the goal and the start, and the for each row and print. Yeah, that should work. Although, yeah, you're missing the A. So after the board start equals A, S, yep, enter. R comma C equals self dot position. Yep, and then, yeah, and that should be good. And you can stop sharing now. Then Nicholas, no, Charlie. Charlie's next, right? Okay. And I believe Nicholas, you'll be after, so just get ready. And yeah, so we just did get valid actions and render. So we'll do Q learning agent. We'll start off with init. So init is basically the constructor for Python classes. Constructor is basically when you call this initialize or initiate this class. So, oh, I think it's instantiate or something. But if you do set a variable equal to QLearningAgent, then you pass in some arguments. And these arguments are going to be LR, which is learning rate, gamma, and EPS means epsilon. And we're basically going to set these arguments that we have uh, passed in to our class's internal mm, internal variables. And yeah, self dot. Whenever you do this constructor, you're just always gonna it's gonna be really easy. It's just self dot something equals whatever argument is passed. So do self dot LR equals LR. Enter self dot gamma equals gamma, self dot EPS equals EPS, which is epsilon. And so some things about this, the self dot thing, you can change the variable name to whatever you want, but usually I just name it the same thing. And the right side is whatever needs has to be equal to whatever the argument variable name is from like the init function. You can see that LR, then we have to use LR. And then you can also initialize variables that weren't passed into the argument, but you want to use globally across your QLearningAgent class. So you can do self.q, capital Q, equals. So this is going to be our zero-filled Q table of shape. So it's going to be like 5 by 5 filled with all zeros, and it's going to hold our Q values later on. So you're going to do numpy or np dot zeros, zero ers, no E. Yep. And then it's going to be a function. Inside the function, we're going to have another tuple. Good job. And then so it's going to be rows times columns, and it's going to be all caps. So all caps rows times calls. So erase the comma and do asterisks. Yep. Comma, capital, all caps, n underscore actions. Yep. And then we'll do the state to index function, which is going to be really easy. So r comma c equals state. So this is just the row and column. And then enter return r times calls plus c. Plus c. But you're going to return that, so place a return at the start. And yeah, that's good. Let's do another one. Select action. These are pretty easy. Delete the pass. So we're basically, with the probability of epsilon, we're going to choose a random action. So do if numpy or np dot random. So that's the library. So do dot rand dot rand, and that's going to be a function. No arguments is less than self dot epsilon EPS. Oh, why does it say ESP? I think we named it wrong. Yeah, EPS. enter, colon, since it's the if statement. Return np.random.choice. And we're passing in all caps, n underscore actions. Enter next line outside of the if statement. We're going to do idx or index or whatever you want to name it. idx equals self dot underscore state to index, so the previous function. Yep, and we're passing in state. So state to index is something called a helper function. It's usually used in classes, and it's basically something called a private function. Although Python doesn't have like the terminology for that, just everything's public. But in C or C++ or more object-oriented programming like Java, I don't know if Java has it, but basically there's something called a public function or methods or variables, as well as private and public. And there's a whole bunch of other ones like virtual functions, etc., but that's not important. And it's something called a helper function, which is a private function, so it's only used inside the class, usually. Now, enter best underscore q, so the best q value equals np dot max, and then we pass in self dot q, and then the index. Self dot capital Q, square bracket, and then inside it, we're going to do IDX, so the index. Yeah. Enter, and then we're going to do candidates equals np dot where, where, WHE, yeah. And then we're passing in, again, soft.q IDX equals, one left. Yeah, comma, equals, best underscore Q. And then right side, we're going to do the zero index. So do square bracket 0. Outside the function. My bad. This is hard to explain. Let me change it. So it should be like this. So it's basically doing self.q index equals best q, and it's returning a list of whatever actually it's returning a tuple of these whole bunch of row columns. And we're going to choose the first one because there can be more than one, what do you call it? Q values that have the same best Q value, right? There can be like 5 of the best options. We're just going to choose the first one. You could also do like random or something, but yeah, it doesn't matter. Enter. Next line. We're going to return the np.random.choice. Oh, we are np.random.choice candidates. And yeah, you can stop now. And Nicholas, whenever you're ready, you can share your screen. I believe Liam and Jordan don't feel Fine with sharing. So we'll just go back to Adam after Nicholas. And Nicholas, is it working? Taking some time. Are you doing the live share or are you doing the GitHub? Live? Why isn't this live share? Yeah, you can go after Adam. Uh, Adam, can you share your screen?
Okay.
Nicholas needs some time. And we'll do the Q-Learning agents update function. Yeah, that one. So basically, we're gonna just apply the Q-Learning formula. So it says it right there. It's basically putting in the state and the action. We're adding it to the learning rate times the target minus the current Q value. So the Q function basically just returns the current state's Q value after doing some action A. So the update function's right there. So you'll do delete the pass. Holy is doing that again. Maybe that's better. Okay. Where were we? Right. S underscore index or IDX, up to you. Sorry. S underscore IDX. So it's just the start index equals self dot underscore state to index. Now we're going to pass in the state, which is passed into the function. Enter next line. We're going to do next state. So do ns underscore idx or something equals self dot underscore state to index. And then we're passing in the next state, next underscore state, which is passed into the function again. Next state, next underscore state. Okay. Enter. We're going to do target equals reward. Enter. If not done. If not done. No underscore. And colon. column, or the if statement. Yep. Enter target plus equals self.gamma times np.max function, and we're passing in self.capital Q square bracket next state underscore index, so ns underscore idx. idx instead of index because we named it like that. Next line, outside of the if statement, we're going to do self.q square bracket s underscore idx as in start index, comma, action. Yep. Plus equals outside plus equals self.lr times. So you can see that this is just the Q-learning formula. Square bracket, circle bracket. Target minus self.capital Q square bracket S underscore IDX, comma, action. And yeah. Nicholas, are you ready now? And you can stop sharing. Okay. Then Nicholas, you can start sharing and you'll do the training loop. Accepted. So it should be the training loop right there, train underscore agent. So we're basically passing in the number of episodes we want, the max number of steps we want, and we want to render every blah blah. So max steps is basically just the argument that restricts the how long a game goes for. So if a training agent goes like left, right, like 100 times, we don't want that, right? So we want to limit it to 50. Now we want to run the number of episodes, amount of episodes of interacting with this grid world. And we're basically gonna return this trained or learning agent. So first, let's do env for environment, or you can do environment, up to you, equals capital G grid world. So that's just the we're just instantiating the grid world class. Remember, it's a class, so you want a circle bracket. And this one, you don't you don't pass in any arguments. So just to enter agent, you want to instantiate the Q-learning agent. No, you gotta do agent equals Q-learning agent. Yeah, yeah. And remember, it's a class, so you want to instantiate it with some variable arguments, right? Uh, Q-learning agent has the LR, gamma, and epsilon, so you want to do, yeah, LR equals 0.1. That's our learning rate. 0.1, comma, gamma equals 0.99, comma, epsilon EPS equals 0.2. Next line, for EP or episode or yeah, EP for EP. No, no, for loop. For loop. Not epsilon, but EP for episode. Remember, we might have a naming conflict between the two, so just do EP in range of one comma range function is a function, comma inside the range function, comma number underscore num under yeah plus one and yep. So what this does, so you know the range function, basically if you pass in range of 10, then it basically returns, you can imagine it like it returns a list of like 0, 1, 2, 3, 4, all the way up to 9, even if you do range of 10. So if you do it like that, it starts at 0 and goes all the way to whatever number minus 1. So basically, you have 10 values from 0 to 9. So that's why when we do range of 1 to number of episodes plus 1, we're basically doing 1, 2, 3, 4, all the way up to number of episodes plus 1. The plus 1 is because of that starting one, right? Instead of starting from 0, we're starting from 1. So we want to add that to the number of episodes. Does that make sense? Okay. For episode. Oh yeah. Also, after Nicholas, we'll go with Charlie again. Oh no, Albert. Albert will go with you next, so just be ready. So for episodes in range of yeah, that's good. State equals env dot reset. So we have this instantiated class, which is env. We're going to set the environment to reset. So we're returning to the state, which is a start state. Tab. Yep. Done equals false. Yep. Enter. So for Boolean, false and true in Python, it's always going to be a capital F or a capital T. Steps equals 0. We're going to be counting how many steps it takes to find out which one is best. Enter. While not done. Uh, yep, not done. No underscore. And steps is lower than max underscore steps. Yep, yep. Colon. Action equals agent dot select action. And we're passing in the state. And it's a function. Holy, what is it? I'm not even touching it. I don't even know. Okay. Select action is a function, so we pass in the state. So by passing in the state, that means we're passing in like an argument to the select action function. So what that means is you basically put a variable inside the circle brackets. So you're giving that select action function the state variable. No need for the equals. Although that can still work, but no need for it. Next line. Next underscore state. It should be inside the, yeah. Next underscore state, comma, reward, comma, done, equals environment env dot step. And it's a function, and we pass in the action variable. Enter. Now we want to update our queue table. So do agent dot update. Oh my. Why is it like that? Function, we're passing in the state. Comma, action, comma, reward, comma, next underscore state, comma, done. Next line, we're going to do state. Oh my God. Okay. I think it's because other people are elsewhere while you do that. Maybe there's a way like, what's that? Whatever. State equals next state. Yeah. Steps plus equals 1. Next line. Yep. Plus 1. That also works. Enter. Now you can optionally put like a visual feedback, but I'll just do it for you. That's the VS Code link. Am I done? Yes, you are. Server offline. Now we want to return the agent. And that's it. Okay, so now we need 3 functions. So let me just quickly explain these two. So we're plotting the value function. So this is the Q value. So basically, you guys know the PLT library. I'm pretty sure, yeah, matplotlib is the library name. Everyone just shortens it to PLT. So this is for plotting. And you basically just say the figure size, the title, what to show, color bar, what do you call it? X axis and the Y axis, like the ticks. So how many ticks there are. Now for each row and for each column, we're just gonna print out some text representing it. And we're showing the plot. That's pretty much it. Now for this one, we're basically plotting the greedy policy. So we have the actions, which is 0, 1, 2, 3, which represents going up, down, left, and right. And we basically have the plots again. We're saying set the axis Y and X and Y. Now for each row and column, so for each cell, we're gonna get the best action. the best vector. Now we're going to draw the holes, which is the whole. So this means the whole whole row and the whole column. So it's basically the x and y values of all the holes. We're going to create this h value. And then we set the title again and then show. So we'll do the play greedy and the animate greedy and the name equals main. I mean, where are we here? Yeah. So play greedy basically pass in the agent that we want, the class, the GridWorld class, so our environment. We have our max number of steps, which is 50. You can change this around, say like 30 or something. And the delay. So we want to run one episode after training. So always picking the greedy action. And then we want to print the board after each move. Next, we want to animate the greedy. So basically doing a matplotlib animation. And yeah, how do I stop? I'm pretty sure Nicholas just went. So Albert, can you share your screen? Whenever you're ready. Play greedy, yep, that one. So we're basically gonna do the greedy search. So play greedy. First, delete the path, yep. Tab, and then we'll do state equals environment.reset. Environment is env dot reset, and that's the function. Function. So the circle bracket. Yeah. No arguments are passed in, so then enter env.render function. Uh, circle bracket, right? So whenever it's a function, you call it using a circle bracket after the statement. Enter, you want to do time.sleep function, and we pass in the delay. Time.sleep, and we pass in an argument called delay. Yeah, that's good. Enter, done equals false, so we want to set done to false at the start. False is capital F. Yep, enter. You want to set steps, the number of steps equals 0, so steps equals 0. While not done and steps is less than max number of steps, so do while not done. While not space done. So while not is a conditional statement, so doing negation. So if it is not done, then do blah blah blah. So we want to do space, and we have another and in English, A and D. You probably do some other languages if you do ampersand, but Python doesn't do that. And steps is lowered less than, yeah, max underscore steps. Yep. And then colon. Enter. Next line. Now you want to choose the best action. So do s underscore idx or start index or whatever you want. Equals agent dot underscore state to index. We're passing in the state. So state2index is a function. And we pass in an argument called state. Next line, you want to do best q. So best q value or best underscore q equals np.max. And that's a function. And we pass in the agent dot. Sorry, that's the argument of the max function. Dot capital Q square bracket S underscore index or IDX. Next line. Now we're going to get the candidates again. Candidates equals np dot where. Yep. And we that's a function, and we pass in agent dot capital Q S underscore index square bracket. S underscore equals sorry, go inside the circle bracket but outside the square bracket. Equals best underscore Q. Now to the right of the circle bracket, you want to still do a square bracket and pass in a 0. No, no, no. Outside, 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 like to the right side, outside of the yeah, square bracket, open one, open as 0. So basically, np.where returns a bunch of a tuple of a whole bunch of things, and we want to just get the first value. And enter. Action equals np so action equals np dot random dot choice, and that's a function, and we pass in candidates. Next line, you're gonna do next state, comma, reward, next underscore state, comma, reward, comma, done. Done. Equals env dot step, and that's a function, and we pass in action. Enter env dot render function. No argument. Enter time dot sleep is a function, and we pass in delay. State equals next state. Steps plus equals 1. And then result, sorry, delete it. Go outside the while loop. Then do result. Result equals success equals the string success. Yep. If E and V inside the same line, inside the same line. So we're doing an inline conditional. If EMV dot POS equals goal. Goal is all caps. Else inside the same line, string failure. Yeah. And then you can stop sharing now. Okay. Play greedy. 1 second. Play greedy. And 40. Let me share my screen. Play greedy. Yeah. Weird. Why is there no return? Okay. And then we can also print some episodes. Episode finished after blah blah. Now we'll do animate greedy. Yeah, we have time. Albert went. Charlie, do you want to share your screen? And we'll do animate greedy. Set read and write. So it should be animate greedy line 378. Yeah. Delete the pass. What Okay, whatever. Greedy underscore action equals np dot argmax, and we pass in agent dot q, capital Q, comma access equals 1, AXIS. Next line. My God, that thing is okay. V equals np dot max function, and we pass in agent dot q, capital Q, yeah, comma access equals 1. Oh, okay. Maybe it's because other people are here. I don't know. At least there's one person. Alright. Axis equals 1. Outside of the function, you want to do dot reshape. Yeah, dot reshape function. Inside the function, we're going to pass in a tuple of rows, comma, cols, all caps. Next line, you're going to do fig, comma, ax, as in figure axis. Actually, maybe we should just skip the plotting. Yeah, I'll just paste the plotting code. It's pretty useless anyways. VSV. Yeah, okay. Tab. So here you're gonna draw the holes. So do for HR comma HC. HR comma HC in all caps holes. HOLES. Yep. Colon. AX dot add patch. Function. Maybe, okay, whatever. Rectangle class inside the function, yep. And that's the class, so you want to do a circle bracket. And we're passing in tuple. So it's going to be HC minus 0.5, comma, HR minus 0.5. Now, outside one tuple, you're going to do comma 1, comma, face color equals string black. And then do another comma. You're going to do edge color equals white. Yeah. And you can stop sharing. I think we can stop here for now. And then we'll finish this function and the main function next week. And then we'll move on to another project. And we can do Blicket. Share my screen. Okay. What haven't we tried? Racing? Royale? Copy the join link. And let me also stop the recording for now. And I will